Hello and welcome to another video. In this video we're going to be working on find common characters. And I think this problem's closer to a medium probably than an easy. I mean, it's not that bad. But yeah, you're given an array of all characters that show up in all strings within the words, including duplicates, and you may return the answer in any order. And so you want to include duplicates, so there's two L's in each one of these, and there's an E, so you return ELL, any order. And then here there's CO. So in general, like, what's going to be the process of figuring out characters that appear in all of them? So what you can do is for every word, we can just make a counter of how many times each letter appears. So for example, in here, we're going to say we have a 1B, we have 1A, 1E, and 2 L's. And then we're going to store this, and then when we go to another word like label, so we can do the same thing. So A is 1, B is 1, E is 1, and 2 L's. So we can just compare these. And in order for every letter to appear in everything, we can just say, okay, so the letter has to appear in both of them. And we're going to take the minimum count. Because, for example, if there's 2 L's here, but there's 3 L's here, we need that letter count to appear everywhere. So in order for it to appear everywhere, if a letter appears in both, we're going to take the minimum of the two values. So let's say E appears twice here and E appears 3 times. Well, we're going to take the E twice because E needs to appear twice in all of these, and E does not appear 3 times in here. So for keys that exist in both of them, you're just going to take the min value. And if a key exists in one and not the other, then obviously that letter doesn't exist in both. So we're just going to say get rid of that. So essentially we're going to take our previous word and our current word and make a combination. And the combination will be if key is in both, take smaller value. If key missing from one, then don't include at all. Right? And that makes sense because, like, if a letter appears in one word but not in the rest, then we shouldn't have that. So here, this is all the same, right? So I think label and Bella is like an anagram, so that's all the same. So essentially what we're going to say, we're going to combine these two, and because they're the same, we're going to just combine them into this. Now for roller, so let's do this again. So for E, we have 1. For L, we have 2. And for R, we have 2. So to combine, A only appears in this one, so A is gone. E appears in both, so E stays. B only appears in left, so B is gone. And L appears in both, the same count, so that stays. And R, it's like this. So the combination would be 1E and 2 L's. So we're going to combine to this, and we basically just keep doing that until we're done. So we just have a frequency of every word, and then for every 2 words next to each other, we can just keep the we can just store the minimum frequency, and if it doesn't appear in one of them, then we can ignore it. And we're going to be using arrays here because I talked about this before in Java. Arrays are going to be more performant than hash maps. So the way to make it an array, pretty easy instead of a dictionary. So we can just take the ASCII value. So I think the ASCII value for A is like 97 for lowercase a. So we can just say, let's take whatever letter we have and subtract the ASCII value for A. That way, if we have a B, for example, we'll subtract 97, and we will get 1 here. So B will be at index 1, A will be at index 0, C will be at index 2, and so on. So we can just make an array of length 26, and then the value in the box will be the ASCII value of the character minus the ASCII value for A, and then we can always convert it back just by adding the ASCII value for A and turning it into a character. So we'll have an array like this for one word and the other word, and then we can just take the min value. So if it doesn't exist in both of them, this will have a 0, and the other one will also have a 0. So we don't have to check, like, does it exist in one, does it exist in the other, all this stuff. With arrays, we can just say, like, okay, we're going to go through our 2 arrays, our previous word and our current word, and just store the min value. And then we're going to keep doing that, and finally we'll have an array at the end of all the stuff. And then at the end, it's pretty easy. So let's say we have like 3 C's or something. We can just say, like, okay, if we have 3 C's, let's add 3 C's and that, and so on. So that part's pretty straightforward. And this is a good habit to get into for Java to get, like, faster solutions, because hash maps have more overhead. So you can just use a static array of length 26 when you know you only have 26 characters. Okay, so that's what we're going to code. So the first thing is we need to have a hash map to start with. So our initial hash map will just be the first word. And then we'll compare that to other words. So we can just say, like, int array we'll call this like our previous word. Yeah. So int array previous equals new int array of length 26. And we're going to loop through every character in the first word. So we'll say it's less than words 0 length. Okay, and now we're just going to take these values. So we'll say previous. So we'll say previous at index. So the index will be the character we are going to have. So I guess we can take the character and we can turn it into a number. So we can call it like character number or something equals integer. And then this will be words 0 at I minus the ASCII value for A. That will give us our index of that we need to increment. And this should be int. And then we can just increment this guy. So I think this is fine. Oh, right, this needs to be character at I. So character at I. Okay. So essentially this will be an array of all the frequencies of all the characters in the first word. Now we're going to loop through every other word. So we'll say int I equals 1. Yeah, I is less than words length I plus plus. And then for each one of these words, we are going to make a new array and then go through all the characters. So we could make another one of these. So we can say like int array, current array is a new array of length 26. And then we need to go through all the characters in the word. This is going to be kind of similar to this guy. So we can copy this. Yeah. So let's just say this is J, J, J. This is not word 0, and then now it's words I. Do this guy. So this is all the same. This is words I at location J. Yeah. And then this is going to be current. So now current will be the character count in our current word, and previous will have the previous word. Now we need to combine the two, and we can combine the two in our current. So we can just say, let's just loop from 0 to 26. So 0 to 26. And let's just take the min value of our current count and our previous count. So we can say current at J equals minimum of our current count and our previous count. And if it was 0, it'll just take the min of 0 and 0, which is fine. So current J, previous J. And so this is what I was saying, like coding in Java like this is a little bit tougher than Python. It's a little bit unintuitive, but it's definitely like gives you good practice of thinking of things that you would never have to consider in Python. That would be a lot easier. So now basically we've kind of combined these two dictionaries, but we use arrays into our current, and now we'll just say previous equals current. So now at the very end, previous will be like the combined frequency count of all the characters that appear everywhere. So now what we need to do is we need to take previous and we need to actually make a result. So we'll say list string result equals new array list. And then we need to loop through every single index in previous, which we can copy here. So use I again. We don't need this guy. What we do need is the character count, and we need the actual character. So let's do that. So we'll say like character count equals our previous at I, and then we need the actual character. So we can call this like character or something, I guess. And this is going to be, it's actually not going to be a character, it's going to be a string. So we can call it string C or something. And we just need this character. So we need to calculate the character. So I think you can do character to string, and then the character that it's actually going to be. So it's going to be the reverse of what we did over here. So instead of converting to an int, now we'll convert to character, and then it will be, so this will be an int. We need to add a to it again. So we'll say I plus a, I believe, works. So essentially, like in this picture, like let's say we're at index 3, this would be 3 plus a, and this would be 97. So this would basically give you the character for D once you convert it to a character. So hopefully that makes sense. And this is integer. So essentially we have an integer of how many of that character we have, and then the actual character. Now we just need to loop this many times and add that character into the result. So we can say for int j equals 0, j is less than character count. So this many times we need to add it to the result. So result add c. Right, and then we need to return the result. So it's definitely pretty decent amount of code for a easy problem. But yeah, let's see what happens. Hopefully I didn't make any errors. Okay. Yeah, and just a small thing. So I usually used to like write this in like another monitor and copy it. Nowadays I kind of like freestyle it, and I think I'm getting a lot better at like actually coding it on the fly and not making mistakes. So happy with that. Okay, so let's think about the time complexity and all that. So we go through every word and we get a character count, which is, you know, let's say we have n words and each word has like W characters maybe on average. So let's say something like this, or maybe W is like the length of the biggest word, something like this. So yeah, we go through every word, do a character count. Then this you can say is O of 1 because we only have 26 characters. And then finally in the result, so for every character that we do get that appears everywhere, we add it to the result. So I think that's going to be worst case this as well, because like let's say imagine every word is super long and every word is just like an anagram or the exact same word. Then you would basically have every character appear everywhere. Actually, no. So worst case scenario, this is actually not worst case scenario, this is not n times w. Worst case scenario, it's only going to be w, right? Because like let's say every word's 100 characters or whatever, and every word's the same, you still only have 100 characters. You don't have like 100 times 100. So this part, worst case scenario, is just w, but going through the whole thing is n times w, and then this we can say is constant time. Yeah, space. So this is why I really like doing character counts for problems, because you usually only have 26 characters. So if these constraints go to like 10k, 100k, whatever, you're only going to have still an array of length 26, which is really nice. So you can basically say that part's O of 1 because it's only 26 every time. Do we have anything else? I think we just have a previous and a current array, which are only length 26. We don't use anything else. We have a result, but we have to have a result that doesn't count. So I think this is just like this. And yeah, so I think I ran it already, but yeah, so pretty good. I think if you run this with a hash map, so if you take a look, I'm guessing the stuff that ran faster is probably not using a hash map. So yeah, so here we have array. Yeah, so you could see this like pattern in Java where if you use an array, it's faster, and then if you look at this, probably a hash map. Yep. So, small tips there for you. And yeah, that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.